Dear students, welcome to the class. I am Dr. Tirupathi Reddy, Department of Mathematics, B.V. Raju Institute of Technology, Narsapur. In this linear algebra and calculus course, today we are going to learn another example on LaGrange's method of undetermined multipliers, which is very, very important for in an examination point of view. Let us see the problem statement. Find the volume of the largest rectangular parallelepiped that can be inscribed in the ellipsoid given by x square by a square plus y square by b square plus z square by c square equal to 1. We will try to find out the dimensions of the volume by using LaGrange's method, and then we compute the required volume for the rectangular parallelepiped. So we have to analyze the problem what they are actually asking. So this is what the ellipsoid. In this we have to keep the largest rectangular parallelepiped. This is what the parallelepiped we have kept. Not only this, we will take another largest possible rectangular parallelepiped. So here let me take another one. We can take bigger version, bigger size largest rectangular parallelepiped. Likewise, we can increase the volume so that the corners of the rectangular parallelepiped should be tangent to the interior surface of the ellipsoid. That is what they are asking. We have to take the largest possible rectangular parallelepiped that can be inscribed. Here inscribed in the sense the corners of the rectangular parallelepiped should be tangent to the interior surface of the ellipsoid. Okay. Therefore we have to find out such parallelepiped dimensions like length, breadth and height, and then we have to compute the volume. So what is the formula for volume? We know. So volume is given by length into breadth into height. So by keeping this basic observation in mind, we are going to take the dimensions. Let the dimensions of the rectangular parallelepiped 2x, 2y, 2z. Then volume formula is given by 8xyz. And what we are trying to maximize the volume, that is the reason we are going to consider f of x, y, z as v. And the condition is given by phi of x, y, z is x square by a square plus y square by b square plus z square by c square minus 1 equal to 0. As per this Lagrange's method, we have to find out the Lagrangian function f plus lambda phi. So here f is given by 8xyz plus lambda times x square by a square plus y square by b square plus z square by c square minus 1. So in step 2, we have to find the stationary points from dou f by dou x equal to 0. It implies when you are differentiating partially with respect to x, y will be treated as constant, z will be treated as constant, x derivative with respect to x is 1 plus lambda times 1 by a square is constant and x square derivative is 2x and put equal to 0. So take 2 common, it will be 4yz plus lambda into x by a square equal to 0. So from this a square yz equal to minus lambda x by 4. It implies a square yz by x equal to minus lambda by 4. This is one of the equation we have obtained, and this you label as equation 1 and the condition as equation 1 and the main function f as star for future use. Similarly, from dou f by dou y equal to 0, we get b square zx by y is equal to minus lambda by 4, and dou f by dou z equal to 0 will gives you c square xy by z is equal to minus lambda by 4. This is equation 3, this is equation 4. So, from 2, 3 and 4, from equations 2 to 4, we are going to get, as the right hand side is same, a square yz by x is equal to b square zx by y is equal to c square xy by z is equal to minus lambda by 4. So, from these first two members, we are going to get a square yz by x is equal to b square zx by y. We are going to cancel z on both sides. You are going to have x square by a square is equal to y square by b square. You send this x to this side and bring a square this side, and send y to this side and b square to this side. It will be y square by b square. Okay, and this is what we have. Similarly, from the other two members, we are going to take b square zx by y is equal to c square xy by z. Both sides x will be cancelled. This can be obtained y square by b square is equal to z square by c square. Now, we have to make use of these relations between x, y and z into the condition. That condition is given by x square by a square plus y square by b square plus z square by c square equal to 1. From this, x square by a square is same, and y square by b square I can write as x square by a square, that will be 2x square by a square, and again z square by c square is given by y square by b square. In turn, y square by b square is x square by a square. You are going to have 3 times x square by a square is 1. 3 times x square by a square is equal to 1. It implies x is equal to plus or minus a by root 3. Similarly, we are going to get the same argument, plus or minus b by root 3, and z is equal to plus or minus c by root 3. Therefore, the stationary points are x comma y comma z is equal to plus or minus a by root 3, plus or minus b by root 3, plus or minus c by root 3. It implies we can find this is what the stationary point, then function value f of x comma y comma z, at which function is going to admit the largest possible maximum volume. Then 8xyz, it is 8 into a by root 3, b by root 3 and c by root 3. This is 8 a b c by 3 root 3. This is what volume cubic units. Okay, so this is what the required largest volume of the rectangular parallelepiped that can be inscribed in the ellipsoid by using LaGrange's method of undetermined multipliers. Thank you for watching. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.